Hi, geometry students. This is lesson 211, but really it's just the review. I'm not going to do all the questions, but I am going to hop around and do a bunch of different ones. And then at the end, I'm going to want to know what other questions do you still want to go over. So see what we cover, and then you decide from there. So the very first one that I'm going to start with is number 2. So it says, dilate the line segment AB, given those points, by a factor of 2 through point O, which is -4, 3. So I've got mine all graphed and ready to go. Write the coordinates of A prime, B prime, express the scale factor symbolically. All right. So for these ones, what you want to remember is that if we are dilating by a factor of 2, the segment should end up twice as big, but also it depends where the center of dilation is as to where the segment lands. So I'm going to connect from O through A and draw a segment, and then from O through B. So the points are going to slide out along those line segments. Right. Now, if we were doing construction, which we'll do, I think, on a different page, or like number 1, if you go back and try that guy, you can use the compass for this. Otherwise, because we're on the graph, I'm going to use the graph to help me. So I'm going to look at the slope from O to A, and that is down 2 and over 1. And I'm simply just going to repeat it since the scale factor is 2. So repeat it just one time. So down 2 over 1. That's where A prime should land. All right. And then I'm going to play the same game. The slope from O to B goes up 1 and right 1, 2, 3. And then I'm going to repeat that just one time. 1, 2, 3, because the scale factor is 2. Now, if the scale factor was 3, I'd repeat it twice. Right? If it was 4, I'd repeat it 3 times. So you always have to remember the original is the first one, and then anything beyond that. So if I connect the dots, there is going to be my new segment. The coordinates of A prime and B prime. So A prime should now be the point -2, -1. B prime, we are now looking at 2, 1, 2, 3, 4, 5. And then the scale factor. Since the scale factor is 2, and you might see me reference scale factor as just SF, right? That should be the longer segment divided by the smaller, but it should always be the image divided by the pre-image. All right, that's number 2. Let's hop on over to the next page. Number 4 is the next one that I wanted to do with you guys. So number 4 says line L is going to be mapped onto line M by a dilation centered at 4, 1. So come over to 4, 1 and plot that point. That's going to be our center of dilation. The scale factor is 1/2. That's why I picked this one. It's a little different. So the equation of line L is given here. So let's rearrange that. If we subtract 3 over, it's going to be y equals 3x minus 3. Right? And so when we go ahead and plot that line, remember, this is your slope, which is up 3 over 1. That's your y-intercept. So we're starting down at -1, 2, 3. And then we're counting up 1, 2, 3 over 1. 1, 2, 3 over 1. Again, on the graphs, always a great idea to use pencil. I am taking a risk here by using pen. All right, so there's our given line L. We are going to dilate it by 1/2 from point 4, 1. So that's my little center of dilation right there. So what that means is that all the points on the line should move so that they're half as far away as they currently are from point C is what I labeled this right here. All right. I would always suggest just pick 2 points that are kind of close by if you can't pick ones that are vertical, or horizontal. So I'm going to use these 2 that are relatively close. I'm going to call this one A just so I can talk about it. All right. So right now I can connect if I like from C through A, and from C through, I'm going to call this guy B. You don't have to show the connection, but it kind of shows how it's the same as the last problem we just did. All right. So the slope from C to A right now is up 2, left 2. So up 2, left 2. Because we're using a scale factor of 1/2, instead of repeating that, I'm going to actually cut it in half. And I'm going to make this up 1, left 1. So from here, I can go up 1, left 1. That point is going to slide in closer. So what I called point A is going to slide in closer. I'm going to call that my A prime. Right? So just so that it's clear for those that are obviously not with me, but watching from home, that is now the 0.32. All right. My B point over here that I chose, which starts as the 0.10. Right now, the slope from C to B is down 1 and over 1, 2, 3. So down 1 and I should say over, I should say left 1, 2, 3. If I cut that in half, I'm going to go down a half and then left 1.5. All right, that's a little tricky, but that's okay. So if I go down a half and left 1.5, woo, that point's going to slide to right here. All right, so my little B prime is landing itself at 2.5 and then 1/2. Now, I don't technically need to do that second point, but sometimes it feels helpful. And if you remember, the reason I don't have to do that second point is that the image, the line we produce, should always end up parallel to the original line. And so therefore, line L should be parallel to line M. And all I need is 1 point on that line to be able to do this. So by having that point A prime and knowing that the slope is going to stay the same, that would technically be enough to do it. So let's try it. Let's see if that worked. So if I continue that slope, I can go up 1, 2, 3 over 1. Yep. Or I can go down 1, 2, 3 and left 1. And I'm going to keep going. Down 3, left 1, down 1, 2, 3, left 1. If I extend that line, it's going to hit right here, which is at negative 1, 2, 3, 4, 5, 6, 7. All right. So my final answer for line M is y equals, it stays 3x and then minus 7 there. All right, so lots of good review within that question. The next one I would like to do is a couple of pages away. Hop on over to 8A. So 8A says, for each of the following dilations, find the center of dilation, find the scale factor. All right, since they're already drawn to find the center of dilation, we want to find what line, you know, A slid to land on A prime and B slid to land on B prime and so on. So we're going to draw those lines in. So you can see how that same concept gets used over and over. So now you do want to draw really carefully. Otherwise, your point might end up a little bit off, which occasionally happens to me. All right, so A to A prime, B to B prime, and C to C prime, they should all cross in 1 point, meaning that they're concurrent at that 1 point. And that on my graph is the point 2, -1. So my center is 2, -1. And then what's the scale factor? Well, if you remember from the one that we did a little bit ago, the scale factor is always the image divided by the pre-image. So what do I mean by that? Pick one that's easy to look at. I would say the vertical is the easiest. So we could do like A prime, B prime divided by AB, and that's going to give me my scale factor. So this is a length of 1, 2, 3. This is a length of 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go. So center and scale factor. All right. The next one's actually on this page. Slide on down to number 10. Number 10 says we have a dilation that maps point A to A prime. Write the rule for the dilation. And then what are the coordinates if you apply it to the second part? So here, dilation we know means you're multiplying. So you have to figure out that value. That's your scale factor. What are we multiplying by? So you can set up a little equation. I can say 8 times what K value gave me 4 over here, and then solve. So k comes out to be a half. And then you could check it if you want. For the y's, you should have the same thing. 4 times what scale factor would give you 2? You can see how it's going to produce that exact same value. So the rule would be a dilation of 1/2. That's your rule right there. Right? What are the coordinates of B prime? The image of B under the same dilation. So now it's just saying, let's actually dilate point B, which is -6, 10. And so you're multiplying. -6 times a half would be -3. 10 times a half, that would be 5. So those would be the coordinates of B prime. All right. I think there's a few more I wanted to look at on the next page. One composition. So I would like to do D with you. This one starts at the point 3, -2. So I'm going to take a moment and get that plotted. And now you want to remember, this goes first. What's closest to the point, the translation will go second. So if we reflect over the line y equals x, a line y equals x is that perfect diagonal. Oops. Try to get it drawn nice and perfectly. Might be a touch off, but that's okay. This is the one transformation I said that's sometimes worth memorizing. You can tell that you're going to go across the line, but how it works is you're just going to flip the x and the y coordinates. So it should land at -2, +3. So if we go over to -2 and up 3, that's approximately where we were saying we should land there. Then we're going to translate that -3, -6. So you're going to go left 3, down 6. So on the graph, you can do it, or you can algebraically do it. Otherwise, left 3 and then down 1, 2, 3, 4, 5, 6. This should be our final stop. So the coordinates of that point should be -5, -3. And if we look, -1, 2, 3, 4, 5, and down 1, 2, 3. So either way, you'll get there. All right. As for what's left, I think there was one last question, that I wanted to do with you guys. Just double checking. Oh, 2 last questions. So 14, and then all the way to the last page. So for 14, what is the image of point -1, 3? So let's get that plotted. After reflection in the line x equals 3. All right, this one I picked specifically because it's easy to make a mistake on this. If it's x equals, it literally means that it only crosses the x-axis, which might be something you remember from Algebra 1 last year. So that makes it a vertical line. So over here at 1, 2, 3, I'll grab my red pen, or if you have a highlighter, this is a great spot to use a highlighter. This is now the line that we're reflecting over. That's the line x equals 3. So there is no rule to follow. You have to use the visual here. Remember, you're always reflecting perpendicular. So since this is vertical, you're going to walk horizontally 1, 2, 3, 4, and then that same distance of 4 past 1, 2, 3, 4, so that it lands over here. And the coordinates of that point, 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. And then that is our answer there. All right, the last question I'd like to do with you guys requires your compass and your straight edge. So get those. Ooh, throwing mine on the floor here. Get those out. The very last question says construct the line of reflection. We did this back on the very first day of the unit. So to construct the line of reflection, you have to be able to look at the diagram and say, hey, I know this point is going to correspond to this one. And what I mean by that, like this point right here, looks like it should correspond to the top corner of like this little moon here, or you could use the bottom too. Try not to pick arbitrary points like, oh, that looks like a point in the middle. That looks like a point in the middle. Try to pick specific ones, all right? With that being said, we are going to construct the perpendicular bisector of that little segment. And that should be the line of reflection. So if I take here, make sure you're opening it more than halfway. Swipe an arc, and then go to the other end. Swipe the exact same arc. All right. Use your straight edge. Connect the dots. And then what you should have created is a line that if you were to fold your paper, ooh, a little blurry there. If we were to fold our paper over that line, everything would match up perfectly. All right. So those are the ones I wanted to do with you. What I now want you to do is look through the rest of the packet. Are there any questions or types of questions that you would like to look at together? Put those as your post-video question answer. Thanks, guys.